This tutorial assumes you have some familiarity with Python 2.7 and that you know how to install packages. If you aren't quite there yet, I'll leave a few links in the description for where you might go to get started with that stuff. Okay, so here's the code I'll be showing you today. You probably noticed that it is 6 lines of code right now, but I'm going to show you how we can squeeze that down to just 4 by the end of this video. First, let's walk through the code shown here line by line. The first line of code is importing the k nearest neighbors classifier from the scikit-learn module. If that sounds complicated, don't worry, it isn't as crazy as it sounds. You can think of the k nearest neighbors classifier as some math that attempts to find similarities between samples in the data set that you use to train your algorithm and the data that you provide when you are trying to classify what something is based on its features. By the way, classifiers are a type of machine learning algorithm that are good at figuring out what something is based on the features that it can observe. More on that later. For now, just think of the k nearest neighbors classifier as like an awesome detective machine that we're going to use to help us out later. The next line is where most of the work you have to do happens. This is where you will be building part of your data set. I've called this variable features to help you think of what these numbers represent. Notice that the features variable is one large list that contains a bunch of smaller lists. These smaller lists are almost like DNA strands. You could also think of them as all the values from a single row of a spreadsheet. You may find it helpful to imagine that the values in these smaller lists represents the features of a single object. For example, the first number in one of the smaller lists might represent height in inches, and the second might represent weight in pounds. Moving through these small lists one at a time, we can see that in our first sample, we are dealing with a person who is 63 inches tall and weighs 120 pounds. In the next sample, we are looking at a person who is 65 inches tall and 140 pounds. Each of the following observations tracks the height and weight of a single person. On the third line is where we store the labels of our dataset. In this example, I have labeled each of the samples as either a woman or a man. Notice that there are an equal number of observation sets in our features list as there are labels, and that they appear in the correct order. We will need to convert these labels into numbers so that the k nearest neighbors classifier can work, but this isn't too difficult. We will change anything labeled woman to a 0 and anything labeled man to a 1. On the next line down, we fire up that awesome detective machine that we imported earlier. I've called our copy of the detective machine the machine. Moving to the next line, we use the DotFit method on our new machine to train our algorithm. This is a little confusing, but you can think of it as just some algorithm reading all of your observations and getting a good sense for how a set of features relates to other sets of features. Notice that the DotFit method takes those features and labels that we created earlier as inputs. Finally, we want to see if our machine is good at applying the correct label to an unknown set of observations. We print the result of plugging new height and weight measurements into our machine using the .predict method. Let's imagine that we observe a man who is 5'5" and 155 pounds. I've entered a height of 65 inches and a weight of 155 pounds as inputs to the predict method of our classifier on the last line. Let's see what the classifier predicts. Remember that we use 0 to represent a woman and 1 to represent a man. In the Python shell, we can see that our classifier is predicting that it is observing a man given the height and weight parameters that we provided. And it happens to be right. Awesome. You may have more interesting projects that you want to use machine learning for. All you have to do is change up the features variable from this code to match your own dataset and update the labels variable to be whatever outcome you are trying to predict. And you will have a working, powerful machine learning classifier ready to help you with your predictions. And by the way, you can have more than 2 features in your dataset. I just wanted to keep things simple for you at first. It really isn't hard to add other features and get even more nimble detective machines. You will want to have more than 7 samples to train your dataset to if you want your algorithm to be decent at classifying. And now I'll show you how to squeeze this already concise code down to just 4 lines. Step 1 is combining our features and labels onto one line. It isn't less typing or code really, and it isn't as clear as just having these appear on separate lines, but we can do that by creating our variables with commas and creating 2 variables simultaneously. Now we're down to 5. Next, I'll take out the final line of the sample code. Recall that I said I could show you how to train your own classifier in 4 lines of code. That's done. Now, when I run this code, our algorithm is trained and ready to go, even though we haven't asked it to do anything yet. I can demonstrate this by dropping that last line in the Python shell after running the program. There you have it, geniuses. Powerful machine learning in 4 lines of code. If this video helped you, I'd appreciate a simple thumbs up. Feel free to subscribe if you dig my teaching style. Thank you and happy coding.